For this video, we are going to be discussing slope. So, slope is a very important concept in geometry, and it's one that we're going to be using a lot as we examine things about lines and parallelism and all sorts of geometric concepts. So it's a very key fundamental concept. And all slope is it is a measure, it's a numerical measure, that describes the steepness of a line between 2 points. And slope is defined as the change in the horizontal change and the vertical change. It's defined as the vertical change divided by the horizontal change. Okay, many times you'll see it written as rise over run. That's an R. It's just a very ugly R. Right? So a lot of times you'll see it as rise over run. It's just the change in y over the change in x. And this triangle here is delta. Okay, delta, and it just means change. So it's simply the vertical change over the horizontal change, the change in y over the change in x. And the long way of writing the slope formula is y2 minus y1 over x2 minus x1. All right, so we simply go do my y value minus my y value, my x value minus my x value, and divide them. That's all we do. So if I want to find the slope of a line, say, here's a line, let's find the slope, all I have to do, take my two y values and subtract them. So I've got 3 and 1, 3 minus 1. Take my two x values and subtract them, 4 minus negative 2. And then I divide. So 3 minus 1, that's 2. 4 minus negative 2, that is 6. So I get 2 over 6, which reduces to 1/3. So the slope of my line is 1/3. You always want to reduce if you possibly can. Now, what does this 1/3 tells us? It tells us our line is not all that steep. The higher the number, the more steep the line. The lower the number, the less steep the line is. All right? So the other way we could have done this, besides simply plugging the numbers in, is I really could have just counted. I could have gone, well, this goes over 1, 2, 3, 4, 5, 6 places, and it goes up 1, 2 places, 2 over 6, 1/3. But you're not always going to have the coordinate plane. Sometimes you'll just have words, so you need to be able to know that you simply plug the numbers in. All right, so let's take a look at another example. I don't know why I have the distance formula on here. It says find the slope of a line between the points M at 5, 3, 5 and N at 7, negative 8. Well, I'm just going to do what I just did. Find the difference in my y values. Negative 8 minus 5. Difference of my x values, 7 minus 3. Negative 8 minus 5, that's negative 13. Over 7 minus 3, that's 4. That doesn't reduce, so there's my slope, negative 3 over 4. And slope we always represent by the variable m. Not sure exactly why it's m, but it is m. Now, I could have done this the other way. I could have done 5 minus negative 8 over 3 minus 7. That would have given me positive 13 over negative 4, which is the exact same thing as negative 13 over 4. So it doesn't really make a difference. These two are equivalent to each other. All right, so not too difficult. Let's take a look at a different problem that's maybe a little more challenging. This one says line AB has a slope of negative 3 over 5. Point A is located at 6, 10. I want to give one possible location of point B. So I know I've got A, and A is at is at 6, 10. And then I've got point B, and I don't know the location of the points there. So I'm just going to call them X, Y. And I know my slope is negative 3 over 5. So how do I find my missing point? Well, it's actually pretty simple. If I plug all of this into my slope formula, I can simply solve for the missing information. So I can say, well, y minus 10 over x minus 6 equals negative 3 over 5. Now I just have two equations to solve. Y minus 10 equals negative 3. That's y equals 7. And x minus 6 equals 5. That's x equals 11. And there we go. There is our... Did I have that right? Yes, I do. There we go. There's our point B. Point B is at 11, 7. Just like that. All we did, simply take our information we know, plug it in, and solve for what we don't know. And the interesting thing is we could have done this a different way. We could have said 10 minus y over 6 minus x equals negative 3 over 5. Then if I do that, 10 minus y equals negative 3. So y equals 13. And 6 minus x equals 5. So x equals 1. So I get b is at 1, 13. You might be going, how can b be at two different points? Well, really it's not. It's really that we have three different points. If I draw myself a line, if I've got A here at 610, that's A. One of my B's, 11.7, that could be over here. Or the other one could have been over here at 1.13. They're just two different points on either side of A. We call them B and C. Now the question only asked for one of them, but I went and found 2 points that were on the line. But you can still see that all you have to do, take the information you know, plug it into the equation, and solve for what you don't know. So now you've seen a lot of what there is to know about slope. Your try-it problem for tonight is to find the slope of this line segment AB.